Okay, welcome back. We're now going to talk about number three from test number four. Uh, this actually went really well for our class. I think we dedicated a lot of time to this and really went about this deeply and did some board work, and I was really proud of how this went. But of course, there's some people who did have a little trouble or may just need a refresher. So we'll go over this. Find the area between two curves is simply, oops, um, yeah, how come I can't scribe? There we go. All right. Area between two curves is simply going to be integral from your boundaries from your top function minus your lower function. And then usually do times dx if you're doing it with respect to x, or times dy with respect to y. And the reason why we do that, imagine that you're drawing all these invisible rectangles. They're really thin. And the height of the rectangles is simply determined by the difference in the y coordinates when you're using a particular x value. And then the width is, of course, delta x, which is infinitely thin, which is why we use a definite integral to do this. And of course, we're going from 0 to 9 here. So my area is very simple, from 0 to 9. My upper function is root x. My lower function, which is 1/3 x, times dx. That's basically all we're doing. Now, I did ask you to do this analytically, so we're going to have to be a little careful here. Probably helps convert root x to x to the lower half power. Again, we got 1/3 x. I didn't leave myself much room, so I'm going to squeeze this in. So when you integrate x to the half, that's x to 3 halves over 3 halves. Minus 1/3 x squared over 2. And of course, we're going from 0 to 9. So clean up a little bit. That's 2/3, and that's times square of x cubed minus x squared over 6, again from 0 to 9. If you plug it in carefully, square root of 9 is 3, and 3 cubes 27, so you have 2/3 times 27 minus 81 over 6. And don't worry about the 0, because that's just going to go away. So you should get 18 minus 27 halves, which will get us 4.5, or you could say 9 halves. And I think this is fine for most people, but I just wanted to go over that. Now, if you're revolving about y equals 3, so here's y equals 3. So this is going to involve the washer method because our region is not completely flush against the axis of rotation, so there's going to be a gap when you do this revolution. So here's our center of revolution of y equals 3. And we have an outer radius and an inner radius to consider. So our washer, the cross-section of our washer looks like this. We have an inner radius and an outer radius. Now, very important to label the points here. They all share the same x coordinates, so we'll use x for each one. We're just looking at one particular washer. But generally, we'll say the x coordinates is x. The y coordinates is easy for the axis of rotation, that's 3. The y coordinate for the inner radius is determined by the function root x. We'll say root x is what y is going to equal, right? Because it's on the graph y equals root x. And y equals 1/3 x for that one. So it's pretty clear that my outer radius is 3 minus that bottom function. My inner radius is 3 minus that top function. So it really depends on the situation that you have. And volume, we go from A to B, and it's pi parentheses RO squared minus RI squared times dx. Because the things that we're taking the area of the whole circle minus the area of the little circle, which is going to be a gap. And with the leftover part, which is the washer, that's the area that we got, and of course times the thickness of each washer, which we consider to be delta x, which is infinitely thin. And we do the integrals because we're adding up all these washers and getting the volume. So we're going from 0 to 9 again. And we can apply on the outside if you want. Your RO squared, which is going to be 3 minus 1/3 x squared minus 3 minus root x squared times dx. So really just writing, not evaluating here. Please do not evaluate. Now C kind of threw a little curveball, but if you understand the concept, it's not that bad. So again, we're still revolving about the, actually, sorry, we're doing cross sections, perpendicular to the x-axis. So let me replicate the curve here. Kind of looks like this. And we don't know what shape this is. This is a really funky shape. But generally speaking, we know that when we're doing cross sections, we simply go from A to B, and it's your area in terms of whatever variable times dx, right? So just from 0 to 9 of 2 sine squared pi over 6x. So there's really nothing else to it. You don't want to overthink it. Simply all you're doing is you're just using the area. And that for a square, of course, you do the area square in terms of x. So you'd have to, figure out how long the side is based in terms of x. And the area of a square is s squared. So that's what part D is going to be about. Of course, that's not a square. That's dealing with an isosceles right triangle. So for that one, again, we're perpendicular to the y-axis. Ooh, okay, perpendicular to the y-axis. Some of you guys did it to the x-axis. You had to read carefully. We put it in bold for a good reason. Notice this leg here. If it were to be extended, it would actually touch the y-axis, not the x-axis, and be perpendicular to the y-axis. So you're going to have all these triangles that kind of look like this. Okay, that's not quite isosceles. You're very sad. That's a little better. And so there are isosceles and the right triangles. Well, remember, the base and height are the same. First of all, the base and height are going to be the legs of the right triangle. And they're going to be the same. So area, we know, is 1/2 times base times height. And if we think about how we're going to determine the base, so again, if we label the points, generally speaking, those are both kind of the same y coordinates. And we're going to have to rewrite each equation so it's x in terms of y. So if you have y equals root x, x of course equals y squared. Or in this case, x will equal 3y. So you're going to have 3y and y squared as the x coordinates for those 2 points. And we want to do right minus left. So our base is x right minus x left, which of course is going to be 3y minus y squared. And the area of the triangle is 1/2 times base times height. That base and height are going to be the same thing. So really you can just do 3y minus y squared squared. So my volume, we have to go from 0 to 3 though, because we're in terms of y. 1/2 3y minus y squared squared times dy, because now you're integrating from bottom to top, so the thickness will be delta y of each triangular cross section. So that's essentially what we're doing there. So that's the case with that one. So I'll end the video right here because number 4 is going to take a while. So that will be the solution for number 3 of the test.